Alright, today we're covering Algebra 2, Lesson 62, using complex numbers. This starts in your book on page 442. We're going to go through some definitions and things here before we actually start working out problems so we understand some of what's going on. This lesson is going to do hopefully a good job of preparing you for your February evaluate, because we've seen stuff like this show up in our evaluate tests, but I couldn't really help you out with it until today, okay? Because this is our day that we're actually covering some of that material. And it's what is termed as complex numbers. So if you remember, like way back early in the year, we covered different types of numbers, right? And the very largest category is real numbers, right? Which means, and into all of those categories, like once we get inside of real, there's rational and irrational, correct? Okay, well, if there's real numbers, shouldn't there be another category, right? What would be the opposite of real? Imaginary, okay, imaginary. If it's not real, it's imaginary. You know, how many of us in here have real friends? There's a lot of you that very few of you actually raised your hand. So if you're looking at, at somebody who didn't raise their hand and like, wait a second, I'm your friend, then you can obviously see what they think of you, that, you're not really my friend. Okay, anybody in here have an imaginary friend? Okay, way too many hands went up. Okay, for those of you in the video, put your hands down. Okay, so obviously an imaginary friend is somebody who's not really there. Okay, and that's kind of what we're talking about, is we're going to talk about imaginary numbers. Numbers that we can work with inside of problems, but in all honesty, don't actually exist. Like, we can't plug them into a calculator. It doesn't mean that we can't actually work with them, though. Okay? So, we're going to start off here with a hypothetical. It doesn't mean that we won't actually see this, but the equation positive or negative square root of negative 16. Okay? Normally written like this, okay? Positive or negative square root of negative 16. That has no real solution because there are no real numbers that when we square them are going to equal negative 16. Because up to this point, we should realize that if we take a negative number and square it, what are we always going to get? We're always going to get a positive number. Is that mine? Okay. Okay, so if we take a negative number and square it, we still get a positive number. So is it possible to square a number and get a negative? No. So that's why we're talking about imaginary numbers here. Okay, so there are no numbers that when squared are going to equal negative 16, or for that matter, a negative number. But the equation does have solutions when a new set of numbers outside of the real numbers is introduced, and these numbers are imaginary numbers. Okay, which is why I've capitalized it and underlined it. Okay? Imaginary numbers. An imaginary number is written in the form of B with a italicized I, BI, where B is a real number and I is the imaginary unit. We actually do have a key for this in our calculator. So you actually see this, if you pull out your graphing calculator, you see where the period is at the very bottom in the very middle of your calculator? All right, I'll pull it up. Let's see here, just so we can see it on our screen. You should see a little yellow I, okay, right where that period is. So we can actually hit second period and work with I. I is that imaginary part, okay? B is that real part, or the coefficient of I. Okay, I is a solution for x squared equals negative 1. And so because I squared equals negative 1, I is the square root of negative 1. So you might have seen me write this up here before. I equals the square root of negative 1. Okay? That's what I equals. Okay? And so if I square I squared equals negative 1. Okay, you might have seen me write a list of that up on the board. Okay, I equals the square root of negative 1. I squared equals negative 1. Okay, and so on and so forth, right? And we can work with more and more complex numbers, which is, what this lesson is about. For instance, if I took I to the fourth, that would be negative 1 times negative 1, so I to the fourth would actually equal what? 1. Okay? I to the fourth equals a positive 1. But anyway, getting back to this, because I squared equals negative 1, I equals the square root of negative 1, right here. Okay, the square root of a negative number is an imaginary number. Therefore, the square root of negative 16 is 4i. And I want to show you how we actually do that. Okay? So if I have the square root of negative 16, okay, the square root of negative 16 is made up of the square root of negative 1 times the square root of 16. Okay, or 16 times negative 1, right? Okay, but because this right here equals I can take I out, and that becomes I radical 16, okay? Because that's the equivalent to radical negative 1 times radical 16, which was my original radical negative 16. Now, do we know what the square root of 16 is? What is it? 4. So I can rewrite this as 4i, or 4 times the square root of negative 1. Okay? So because the square root of negative 1 equals I can always take out the negative. That negative becomes I on the outside. Okay? How many of you, do we have any thumbs up, thumbs down, thumbs kind of sideways? How many of us are all the way down, don't get this at all? Anybody don't get this at all? Okay, we got some sideways. All right, hopefully we'll clear a bunch of that up as we go. Okay? An imaginary number bi with that coefficient in front of that I, or coefficient times the square root of negative 1, is part of a complex number. A complex number is a number that can be written in the form of a plus bi, where a and b are real numbers. In a complex number, a is called the real part and bi is called the imaginary part, because we're taking a real number times an imaginary number. So if I take a positive number times a negative number, what am I always going to get? A negative number. Okay? If I take a real number and multiply it by an imaginary number, the same thing applies. I'm always going to get an imaginary number. Okay? The same way if I take a rational number and multiply it by an irrational number, I'm going to get an irrational number. Okay? If I take 2 times pi, I'm going to get an irrational number, right? Because pi is irrational. If I double pi, I'm still getting an irrational number. Wobble your head up and down like you understand me. Okay, great. Okay? So I can get a real part plus a real number times an irrational number. I'm still going to get an an imaginary number. Okay? So if b equals 0 in that equation, okay, a plus bi, then the imaginary part is 0, because anything times 0 is what? 0. So if I take something that is imaginary and multiply it by 0, I'm going to get 0 for the imaginary part. It's going to cancel out if it's 0, if b is 0. Okay? Then, but if a equals 0 and b does not equal 0, then I have 0 for my real part. All I'm left with is the imaginary part. And the number is just going to be the imaginary part. So here's an example. Okay? A complex example is 2 plus 3i, where this is a plus bi. Okay, I've got a real part, which is 2, and I've got an imaginary part, which is 3i. Okay, I can get a real example, though, if I take a real part plus 0 times I. Because that imaginary part is times 0, it cancels out. So I'm left with just 2. I have a real number. But if my real number is 0, and I have something that's not 0 for the real part of my imaginary, then I'm left with only the imaginary. Okay, so I just get an imaginary number. Okay? All right, are we lost yet? No? Some of you are, some of you are not going to admit it. All right, so this, and you'll find this in your book, this is how I add or subtract complex numbers. We're going to refer back to this page in order to do that. So all they're doing here is they're putting A and B in place of numbers that would go there. So if I have a number here and a number here, and I'm adding these things together, I'm going to let's see, I'm going to change the association. Because this is all plus and addition is commutative, I'm going to commute C over to A, and then I'm going to add the B's and the D's and multiply them times I because they're both times I. So I'm going to get A plus C plus B plus D times I. And that's how I'm going to add them together. Okay? And then I will get an answer that is in A plus BI form. Okay? Down here, okay, if I want to subtract, okay, I'm going to subtract here and here, the same order, A minus C plus B minus D, okay, and I'll probably get either an A plus or minus BI, okay, is my final answer. Okay, so I'm just commuting an associative property, doing those things. That's a really terrible sentence, but hopefully we'll understand this as we begin to work out some problems. Okay, and I believe I sent this to you. You guys can check. Did you guys get this page right here? Okay, so let's go through this. 7 times the square root of negative 99. What can I take out of that square root? Anybody tell me? I can take out, but what does it become? It's not just, I'm not just writing -1 on the outside. No. Okay, so you're not wrong. Let's talk about that. That would be square root of 99 times square root of -1, right? Okay, what do I substitute instead of square root of -1? What am I going to write? I. So this is 7i square root of 99. Now, can I simplify the square root of 99? No? What can I divide? Well, I heard somebody say no. I'm not saying you said no or whoever said no. Okay, but what can I divide 99 by? 11. Okay, what's 99 divided by 11? 9. Can I divide 9 by anything? 3. And I get what? So what do I get to pull out from that square root? 3. So I have 7 times 3 times I times square root. What stays in the square root? 11. So what's 7 times 3? So I have 21i radical 11. Does that match any of our answers? What is it? A. Okay? So if you haven't yet, you need to write down that work. Hopefully that you understand it. I'm trying to break that down as much as I possibly can. Okay? Does this make a little bit more sense now that we've worked out a real problem? Yes? Okay. I'm going to erase that. If you didn't get that written down, you can go back and watch the video. That'll get that here in a little bit. Now, number 2, solve 2x squared plus 18 equals 0. Write the solutions of I if necessary. There's a few different ways to do this, but I'm going to try to keep this as simple as possible. We want to solve for x, which means I want to get everything else over to the other side, correct? All right. What's the first thing that can go to the other side? I can subtract 18, that's right. So I can get a negative 18. So I got 2x squared equals negative 18. Now what can move over to the other side? The 2 by dividing by 2. All right, so I get x squared equals negative 9, right? Okay, now what do I want to do to just solve for x? Square root it. Okay, but what you want to remember is that that can be either plus or minus square root of negative 9, right? Okay, so x equals plus or minus square root of negative 9. Now, think back to the last question that we did. Can I split that into 2 different radicals being multiplied by each other? What are they? X equals plus or minus square root of 9 times what? Times I. Okay? Can square root of 9, what is that? 3. So I get x equals plus or minus 3i. You follow me? Okay. All right, so we get x equals plus or minus 3i. The number one thing people forget is that that can be plus or minus, because if I take and I square root the negative, right, I'm going to get a positive. All right, if I square root, or sorry, not square root, but square the negative, I get a positive. If I square root the positive, I get a positive. Okay. Okay. Questions there? A little bit better, a little bit worse? Better. Okay. All right. Number 3. We want to write the answer in the form of a plus bi. So this is going to go back to that slide where we talked about adding and subtracting complex numbers. Okay? So we want to rewrite this. All right, where this is a, b, c, and d. Okay? What's the first thing I'm adding together in that first set of parentheses? A plus c, right? So it should be 6 plus negative 4, or 6 minus 4 plus b plus d, right? What's the b here? 5 plus what? What's the coefficient in front of I that we don't see? 1 times I, right? Okay, so what is 6 minus 4? 2. What is 5 plus 1? Times I. Okay, so I should get 2 plus 6i. Is that hard? Okay, we just have to remember that it's a plus c, okay, plus b plus d with the I on the outside. Okay, 2 plus 6i. Let's see. Slide us down here. Number 4. Okay, number 4. Okay, this one I solved by completing the square. And I don't know if you remember. Do you guys remember how to complete the square? No, not many of us do. Okay, so we'll have a refresher on that. X squared plus 6x plus 18 equals 0. Whenever I want to complete the square, I take this term and move it over to the other side. Remember that? Okay, so that's going to give me x squared plus 6x, and I'm going to leave a blank spot here, equals negative 18. Okay? All right, then I'm going to take this term, I'm going to bring it down here, I'm going to divide it by 2 and square it. What is 6 divided by 2? 3. What's 3 times 3? All right, so then I'm going to take that 9, I'm going to put it here and there. Okay, then I'm going to get this. Okay, so I'm going to use this part right here. I want to factor it down. So I should get x plus and x plus. Okay, what should go in there? 3 and 3. So what that is x plus 3 squared equals negative 9. Okay, how many of you are with me up to this point? 1, 2, 3, 4, 5. Okay, all right, we're getting there. All right, what do I want to do to solve for x? Square root both sides. Square root both sides. Okay, but as I do that, what do I need to remember to include on the right-hand side? Plus or minus. All right. Now, can I go ahead and simplify this? Do we already know what that's going to be? What is that going to be? 3i. Very good. We're getting there. Okay. Now, what do I need to do with the 3 on the left-hand side? Subtract it. So I get x equals negative 3 plus or minus 3i. We always want to put the I on the right-hand side. Okay? Negative 3. So A is my answer here. Negative 3 plus 3i or negative 3 minus 3i. That's the same thing. Okay? It's negative 3 plus or minus 3i. How many of us are feeling a little bit better? Okay? Handful of us are feeling a little bit better. Okay. All right. Number 5 does some of that work for us, right? It skips down to where we got on that last question. So what do I want to do with question number 5? Square root both sides. Very good. Okay? So I'm going to get what? How do I rewrite that? X plus 4 equals what? Plus or minus 4i. Okay, now what do I want to do with that 4? So what do I get? X equals negative 4 plus or minus 4i. We getting better yet? Okay, good. Okay, the more examples of these that you watch and work and write, the better that you're going to get at this. Okay? All right. Number 6. Okay. So we're going to do what we did in the other couple questions up. We're going to solve by completing the square. What's the first step in completing the square? Subtract 5. So that's good. Oh, messed that up. Okay. So as I do that, I'm going to get 8x squared minus 12x equals negative 5. Is that right? What do I do with the negative 12? Divide it by 2 and square it. What's negative 12 divided by 2? Negative 6. What's negative 6 times negative 6? Positive 36, right? All right. So we're hoping to get something squared there. And what's negative 5 plus 36? Would you say 39? 31. Ooh, that doesn't really come out to anything very nice so far. All right, let's look at this. We've got 8x minus 12 plus 36. This may not come out so nice and easy, right? Because, I mean, we don't have two numbers that are the same thing that are going to multiply to be 8, right? There's not like a 2 and 2 or a 4 and 4. Okay, so what we're going to do is we're going to do something a little different here. Okay? Okay, what we're going to do, something called the quadratic equation. And the quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a, where this is a, this is b, and this is c. And this sign right here, this opposite, or that negative means the opposite value of b. Okay? So, the first thing I'm going to write is I'm going to look at where my b is. What number represents b? Negative 12. But because I want the opposite of negative 12, what am I going to write? 12. So 12 plus or minus. Okay? Now I want the value of b, and I want to square it. So what is the value of b? Negative 12 squared minus 4. What's the value of a? 8. What's the value of c? 5. All over 2 times the value of a. What's the value of a? 8. Okay, so we want to simplify this as we go. We have 12 plus or minus. All right, we know that negative 12, so we want to solve what's inside the square root. So negative 12 squared is 144 minus 4 times 8 times 5. Can anybody tell me what that number is going to come out to? What is it? What was it? 160? Yes? So what's negative 12 times negative 12? 144 minus, what's 4 times 8? 4 times 8, what's that? 32. What's 32 times 5? What's that? So 144 minus 160 is what? Negative 16. Were you guys saying that? Because it sounded like you were saying 160. Oh, okay. We want the value of the whole thing in here. Okay, so that's the square root of negative 16 all over what's 2 times 8? 16. Okay, can I simplify this square root of negative 16? What is that? So I have it 12 plus or minus what? What is the square root of negative 16? It's not 4. It's 4 what? 4i. Are they the same thing? Is 4 and 4i the same thing? No. Okay? Over 16. Now, I can reduce those fractions down, right? What's the reduced fraction of 12/16? I can divide them both by 2, and I'm going to get 6/8. Okay, I can divide both those numbers down by and get 3/4, right? So that's 3/4 plus or minus 4 divided by 16. What does that reduce to? 1/4. So that would be I over 4, or 1 over 4 times I, which is why I get A for an answer. Okay, so this equation right here is an important one to know. Okay, we've got enough time here. So that's what we use there. Does everybody understand how we use that equation? Okay, all right. How many of you have seen that equation before? Small handful. Okay, so not completely unfamiliar. All right, question number 7. For the complex number 10 plus 12i, what is the real part and what is the imaginary part? Can anybody tell me what the real part of that equation is? 10. Good. What is the imaginary part? 12i. That whole section is imaginary. Okay? So, real, imaginary. Okay, not too hard there. Let's look at our next one. Okay, solve negative 9 squared equals 1296. Well, if I'm just trying to solve for x, I got negative 9x squared equals 1296. If I'm trying to solve for x, what do I need to do first? No. Divide by negative 9. Okay, so what does x squared equal? What's 1269 divided by negative 9? Negative 141? Yeah. Negative 144. Okay, now what do I need to do to both sides? Square root. Okay, so x equals, is it just that? Or what should go out in front? Plus or minus what? 12i. Okay, x equals plus or minus 12i. Okay, do we understand that? Anybody not understand that? Do I need to go back at it? No? Okay. Let's see, number 9. Okay, simplify negative 9 times the square root of negative 36. Can I simplify the square root of negative 36? What is it? 6i. Negative 9 times 6i. What's negative 9 times 6? Negative, what's 9 times 6? Negative 54, what? I. Negative 54i. Okay? So imagine that it's just a normal square root, except because there's a negative, that negative becomes our I. Okay? Last question. We've got time. So let's do this. Solve the equation, write the solution in a plus bi form. Okay? Let's see. We can solve this by completing the square. What should it equal on the right-hand side? Negative 30. What do I want to do with negative 10? And square it. What's negative 10 divided by 2? What's negative 5 times negative 5? Positive 25. So we add that to both sides. Okay, what's negative 30 plus 25? Negative 5. Okay, I should get x minus in here, right? X minus what? 5. Okay, what do I want to do with both sides? square root. As I do that, what goes out in front of the square root on the right-hand side? Plus or minus the square root of 5, or negative 5. Okay, let's see. What can I take out of that square root on the right-hand side? The negative, and the negative becomes a no. I take out the I. X minus 5 equals plus or minus I radical 5. What do I want to do with the 5 on the left-hand side? To the, okay, x equals what? 5 plus or minus I radical 5. Okay? Do we understand this better than when we started? Do we understand it well enough to get started on our homework? Okay.